All right, gang. The unit of force that you most commonly see, force, is the Newton, N-E-W, actually it's lowercase, N-E-W-T-O-N, because we're not talking about the actual person. The symbol for it is a capital N, right? So you see, oh, this box is being pulled with 150 newtons of force. So I just want to go over what an actual Newton is. That's the worst arrow ever drawn. So it comes from this, right? Force is equal to mass times acceleration. And so we can abbreviate that. Force equals mass times acceleration. And if mass is in kilograms, right? Typically we measure mass, the base unit, in kilograms. And you multiply that, so I'm going to put that over 1, and you multiply that by acceleration, which you guys know, right, is meters usually per second squared, right? So I'm going to multiply mass, that's this one, by acceleration, which is meters per second squared. Nothing cancels, right? The kilograms don't cancel, the second squareds don't cancel, so you just carry that over and you write it like this: a kilogram meter per second squared. So kilogram times meter per second squared. Well, that's a multiplication sign there. Kilogram meter per second squared. Scientists don't like to write that out all the time. So in honor of, Sir Isaac Newton, they just take this whole thing and say, yeah, I don't feel like writing that out all the time. So we'll just create this new unit called the Newton. And every time you see that capital N, you know we really mean kilogram meter per second squared. So bottom line is the Newton is the same thing as a kilogram meter, keeps doing that, kilogram meter per second squared. Scientists don't like to write all that out, so they just shorten it up, call it a Newton. It's lowercase because we're not talking about the person, we're talking about the unit. If we were talking about the person, it would be a capital N.